Good afternoon. My name is Joel Bittner. I'm the General Manager of Placer Mosquito and Vector Control District. I'm going to give you an update on our mosquito control work using drones. Since 2017, we've been working on using drones to do a number of things in our mosquito control workflow. Everything from scouting for habitat using cameras, detecting larvae both above and underwater, mission planning, making treatments, we use the DJI Agris MG1S, and then confirming efficacy of our treatments and making sure that we're doing a good job. All of these elements working together are really what we're striving for to truly integrate UAS technology into our agency. I want to start off by giving you a little case study. This is a treatment we did earlier this spring with a liquid larvicide. This is a Bacillus thuringiensis israeliensis BTI application for snowmelt mosquitoes in Squaw Valley, California. This is our first in the area and first at this altitude. This is about 6,000 feet. Squaw Valley, for those of you who have not been there, is the site of a previous Winter Olympics and is surrounded by mountains and snow. And when that melts in the springtime, it all drains down into this basin. And as you can see from this picture, there's a golf course, there's some permanent lakes, there's some vegetated ponds, there's the Truckee River, and there's some marshy areas that basically collect that snow melt. These marshy areas are really the ones that are of most concern to us from a mosquito standpoint. These snowmelt mosquitoes can hatch and then become a major nuisance to the residents in this area. These vegetated ponds are also a mosquito source and is something that we need to deal with. The lake and the river actually don't produce very many mosquitoes, so we don't want to treat those and really target our areas just to those that produce mosquitoes. In the past, this has involved walking through these areas with a backpack. So we think we could do better with the drone. So we used our previous applied research project information and identified that our MG1S using a liquid Vectovac 12AS product diluted to 1 gallon an acre, flying at about 10 feet, swath of 18 feet and about 11 miles an hour will achieve what we want to. We've tested these protocols in rice fields and other places down in the valley, but this would be the first time we tried it up against snowmelt mosquito species and also at that altitude. So here's what our treatment looked like. The areas that were generally free of vegetation got hit really well. The areas that were flooded but under the vegetation had a little bit harder time getting that product in there. Everything that you see that is green and most of the brown grass is, if you were to stand out there, is about knee deep in water. So we wanted to treat various different areas, and so this was our first site. If you notice the bushes in the background, these were a bit of a problem since they were below our release altitude, our application altitude. And they weren't straight up and down obstacles. They overhang. There was a little bit of a wind, and that really caused problems in terms of planning the mission and setting the spray block. These undercut areas were difficult to identify, so either you have to swing way around them and you miss some areas, or you get really close to them and you risk touching the aircraft on the vegetation. Neither are real good solutions or real good options. All right. So this is a map of the areas that we treated. Scott Schoen, who's on this meeting, was the pilot for this, and we had very varied success. We had, again, areas that had very open water, minimal amounts of emergent vegetation had really good kill. Places that were more vegetated or had canopy or trees or barriers or obstacles that we had to navigate around were less effective. And then areas like in here where there were pockets of water with trees and things like that, we decided actually for safety reasons not to treat those areas because we couldn't get out there and delineate those edges of those spray blocks without actually getting into about chest deep water. So that just didn't work out. All right. That treatment was indicative of a lot of our work over the past couple years, where we're trying to figure out, what are the best uses for drone applications in mosquito control, and trying to match up the equipment that we have with the sources and the needs that we have in the field for treatment. So another ongoing project that we've been working on is a liquid larvicide application optimization trial. So we really want to figure out what is the baseline parameters for a drone application for liquid larvicide. What's the right height? What's the right speed, nozzle configuration, product? And we really want to figure out, how do we get the most out of the machine that we have? We understand that there's multiple choices in machines, but since we have the one that we have, we really want to see what it'll do. We have a project that's ongoing. We collected some data very recently, and we hope to publish some of this data later on in the fall. So where we started is where everyone starts for an application, is with the calibration. So with our DJI unit, it has a built-in calibration function. We've also verified that generally works using standard on-the-ground methods of calibration. We did notice in our last trial that we had some clogging issues that caused some of the nozzles to perform differently than others. So that's something we're going to be watching for. Just a couple weeks ago, we did a trial with a product that's new to us with the drone, a product called Natular, Liquid Natular. It's a spinosad product, and this is an image of our trial setup. We have 3 reps, and we have chroma coat cards. We sprayed a dyed application. And then we have cups that we will then use for bioassay to determine the efficacy of those doses that we applied. So we fly the drone right along that yellow flight line to make sure that we can line it up as best we can with wind and everything else. We make our passes, collect the cards, scan them, and then do a bioassay on the cups. Okay. Here's a picture of the bioassay cups. We add water to them, add larvae, and then take a mortality measurement at 24 hours. So far, it seems like it's working pretty well. The results are important to us, but also having the protocol kind of tied down so we can repeat this with different products, with different heights and speeds, maybe even different drones at some point in the future. All right, so what have we learned so far? Really, with our experience with the drone that we have and using liquid BTI, we've determined it's not a surprise that pastures, wetlands, and areas that have minimal emergent vegetation work pretty well. These are the same places that other applications of this product work, but it's also places that we're easily able to access with the drone, and they are of a size that make using a drone to apply product efficient. So here's an example of an edge of a field and a ditch. That's not fog, that is smoke from the fires this summer. The pros of using liquid obviously is lower cost. We get better coverage because less goes further. The downsides are liquids don't tend to be residual, so we have to make repeated treatments, and obviously they don't penetrate through those canopies or vegetation very well. Okay. A lot of mosquito control districts also use granules from a drone. It's something we're just getting into, but these may be very, very helpful in picking up the slack that a liquid system won't work as well in. This picture is of another snowmelt area, but this dark area is water. And while it looks pretty open, and if you walked up to it, you could spray it with a liquid. From a drone, because of these trees, you can't really get low enough to get a good dose in there. So we're still kind of working with this idea, but we feel that this might be a good candidate for a granular application, so we can kind of penetrate that longer distance, get through the tree canopy. We also have the option with granules to put out residual products or put out products that pre-flood. So one idea is even to try to treat the snow or the areas near the snow and allow the product to melt into the snow melt areas, so we can time that treatment right when those larvae emerge instead of potentially missing them. The cons on the granule side, obviously, it's more stuff, it's heavier, it requires a larger payload, and they tend to be more expensive. Now, some of that can be mitigated through the actual aircraft itself, and there's examples of those as well. So speaking about aircraft, and ours in particular, I would say the biggest issue is the inability to accurately map the spray block. If there was a scout drone where we could go and actually use some of the generally available visual or even sensors like LiDAR or mapping sensors, we could identify a spray block, draw it out on the using the scout drone, load it into the spray drone, and I think that would be a much better solution. To our knowledge, that doesn't exist in a very operational manner yet. All the pieces are there, I just haven't seen it put together. Our drone doesn't have a camera, and for those spot treatments or long ditches and things like that, it would be nice to do a manual option for some treatments, and that makes it really hard with our aircraft that does not have a camera. Battery time, flight time, that's an issue for everybody. And then ultimately, beyond visual line of sight is something that I think would be helpful in this field. Adding detect and avoid and some of these emerging technologies may be something to look at down the road. Okay. Finally, our spray system limitations are probably our biggest problem. Some of these spray systems are not maybe as well thought out as the aircraft part of the apparatus. Not having the selection of nozzles or the pump pressures or the configurations to deliver the droplets and the swath widths and understand and mitigate the drift for some of these treatments are all things that we need to work on. With our aircraft here, this is a backlit spray trial where we're just trying to see what do these spray nozzles do. Unfortunately, it was inside because it was raining that day. But just understanding this from an application and also a regulatory perspective. And I know there's other speakers here today that are going to address drift modeling and so forth. All very, very important work. In summary, here again are our missions. These are the ones that we really want to go for and make UAS work for us. Habitat assessment, get out there and fly and get our eyes in the sky on our habitats. That seems to work really well. Larvae detection is still kind of a work in progress. A liquid and granular larvicide application system, a lot of work there as we talked about. And then the mosquito adulticide, that is something that I think is a little bit of a ways off, but hopefully in not too very long I can come back and report on some efforts on developing mosquito adulticide application systems and use cases and so forth. And to close, I just want to acknowledge our staff here at Placer Mosquito and Vector Control District, especially Scott Schoen, our pilot, Everardo Ortiz, our other pilot. They are responsible for making all of this stuff work safely. Jake Hartle, Mario Boisvert, who's no longer with the district, but were instrumental in planning and making all of this happen. And then all of our other folks, consultants and suppliers that without them we couldn't have done this. So thank you all very much.